Hello, I'm Francis Bitonti, Francis Bitonti Studio, in case you're wondering where the name came from. Named it after my favorite thing. So this is where my work started. I wasn't really an architect, I wasn't a designer. I was really interested in what computing can mean for us culturally, what it could mean for aesthetics, what it could mean for form. The interests were really pretty abstract in the beginning. This is a rule, it's for an algorithm, it's called a cellular automata. And they're just simple neighbor-based rules. Pixels on a page, they're on a grid. Depending on what the context is, it'll flip it black or white. And what'll emerge from that are pretty complex patterns, complex behaviors. And this is really what got all the work started. Nobody drew this. It wasn't conceived of by anybody. It just grew from a set of discrete interactions, and the global intelligence here emerged from just simple neighbor-based behaviors. So why is that? How is that relevant for design? This is the Vitruvian Man. Now, it's a mathematical model. Computation is a way of seeing the world. It's a way of interpreting everything around us and a way of interpreting our relationship to the world. We've done this all throughout history. The Vitruvian Man is our way of understanding ourselves in relationship to our environment, right? You're understanding the body in relationship to a mathematical model, in relationship to Euclidean geometry. The body sits within a circle and a square, pure geometric shapes. The body's the center of all those shapes. You're the center of your world. This was a Renaissance idea, and if you look at a lot of Renaissance design, particularly Renaissance architecture, the idealized forms were centralized. They reflected this theory. Then, Copernicus comes along and he draws this drawing here. And we realize the sun's the center of the universe, right? So then you get the Baroque, and it's okay to have ovals, So it's on a subconscious level, but these mathematical models deeply impact culture. And I see computation as a new kind of paradigm that, be it through social media or be it through anything, has permeated culture. And I think it's something that designers need to be responding to formally. It's not just something abstract. It's not just a data set. It's something that structures our interactions, and it's something that needs to be reflected in physical form. So these are two drawings. So this is next to the Vitruvian Man is what I consider to be the contemporary Vitruvian Man. It's a drawing by an artist named Stellark. And what's interesting about this drawing to me is that, the body's just a node in the network, and it goes so far as that the body's not even symmetrical. The body has two hands. The body's broken into parts. There's sensors connected to different parts of the body. The body's made discrete, and it's just a node within a network. It's a very different way at looking at the human, a very different way at looking at our psychology. And this is the equivalent, I think, of the Copernican map, right? It's the map of the internet. It's a network. It's a set of complex hierarchies. So these things together, this is really what drives the work. What drove the work initially? I mean, it's become much more than that now. But this was the initial investigation, and for a long time, it was really just about drawing. It was about seeing what kinds of new morphologies could emerge by really following computation, just exploring discrete operations that could be done on three-dimensional form and three-dimensional objects without worrying about material, without worrying about any means of production. Just letting the methodology bring meaning into the form, into the project. I tried to be an architect, and I made stuff like this, and I was really confused why they didn't want to build that. But anyway, but somebody actually did at one point. This is what started the studio. The New York City Department of Transportation was looking for designs for a bicycle rack. They were trying to encourage cycling in the city. And I submitted this kind of crazy set of drawings, and they said, "Oh yeah, you're a finalist. Now you got to figure out how to make it." And I didn't know how. So we tried everything. I didn't want it to be carved. I didn't want it to be made by a sculptor. That would have been the only option. I do consider myself a designer. I don't consider myself an artist. And a big part of the work is about engaging production, engaging manufacturing, and engaging technologies that are scalable, if not scalable in the way that we know them now with a kind of industrial manufacturing paradigm, but at least something that could lead to some sort of model of production that will influence economy and larger culture. So these are some prints. These are some photos of the bike rack being printed at the time. It was made in ABS plastic. The thing was then actually car painted. It was covered in Bondo. Another thing that was really important on this project was that I was trying to discover a sense of materiality in a design process that had no materiality. I was trying to capture what that shader was on the computer, that kind of sense of artificiality. There seemed to be a different kind of aesthetic there. It didn't make sense to express materials. It didn't make sense to show a wood grain or stone, or it wanted to be something other. So there was a lot of effort taken in order to sort of capture what I would consider a sort of aesthetic of the digital. These are some shots in the painter's booth, and that's the final piece. And I'm really happy because people still think it's a rendering. And then this is one of the ones that was actually installed in the city, and it was stolen in a day. So that was flattering, but also disappointing. And I've carried these investigations, and this is what started my interest in materials. I started my interest in production. These are some earlier pieces I did. This is a mirror. We've done architectural spaces, interiors. We've done furniture. And always trying to find new forms that, people, I always get upset because people call this like an art chair. It's not a sculpture, and yes, it's complicated, but this is the language of mass production now. These are the kinds of things that we can do with technologies that can be integrated into factory production, factory scale production. We're free from the kind of language of modernism at this point. It's not something that we have to contend with anymore. And that's the point really we're trying to make. And in the past, I guess, 2 years, I've started to move into fashion. And this was the project that started it. It was a belt that I designed for a designer in New York. Her name was Katie Gallagher. And it was a small label, is a small label. And to do an accessory like this would have been incredibly expensive. The molds would have been expensive. It's stainless steel. The entire thing is 3D printed. All the hardware is custom. Nothing about this can be bought off the shelf. These are some of the looks that are integrated, with the belts integrated into the looks on the runway. Some more product shots. This is the technology we use. So one of the biggest problems with these technologies is finishing. This is a prototype from the table leg. It's the same technology we use on the belt. This is how it comes out of the printer. It looks like dirt. It's not something that will sustain a luxury price point, and even though it's incredibly expensive. So a lot of the research that I've been doing has been about finding finishing techniques that can make these things attractive and still give us sort of tactile sensibility that you would expect at a price point like this. These are the finished pieces polished. We're still working on some methods of polishing the interior. I think it's going to have to be a chemical process to get in there. And it was finished twice. This one's a bronze-coated finish, same belt. And all the studs, everything is 3D printed and can be ordered on demand. So the designer didn't have to carry an inventory. So I started, after this project, I kind of started to realize that maybe there was an interest there, and I was always interested in engaging the body. I was always interested in fashion, and I wanted to take the collaboration further. So the next season, we started working together on textiles. And we developed these really intricate kind of laser-cut textiles. These are some sleeves. So what was interesting about these is that they're generated for the pattern. We used flocking algorithms to generate all the line work, and we used the designer's two-dimensional pattern to create a container. So if you were to imagine like a school of fish inside of like an oddly shaped box, right? So you could kind of harness the sort of swarm intelligence and let this sort of morphology emerge. And something that can be aware of the context, something, if you notice like on the sleeves, one of the most successful parts is this kind of spiraling along the sleeve, right? Because we can create a system that's aware of the global geometry and something that can respond to the form, and it becomes a very three-dimensional process. And a lot of what I find working with a lot of fashion designers is that it tends to be two-dimensional. With these techniques, it allows us to conceive form in 3D, and it actually makes the pattern-making process a lot faster. There's just some details here. One of the goals that I think we had worked out together was that we wanted to dissolve the silhouette. That was where all this kind of porosity came from. We wanted the body to kind of be dissolving into the atmosphere. And I love this image because I think it shows we're successful. These are her patterns in the computer. This is some of the results. We also did a collection of belts. These are laser-cut cowhide leather. And if you look at these, this is, we're not only controlling the line work, but we're also controlling the thickness. So we're getting variation in the thickness. And actually, each one of these belts, when ordered, they're all parametrically designed, and each one is slightly different than the other. These are some belts on the runway. So this is probably the project that I'm most well known for, and what's something that's really kind of propelled me into these kind of continued fashion projects. This is a fully 3D printed gown we did for Redefining with a designer based out of California, who's known for Hollywood wardrobing, Michael Schmidt Studios. The entire gown is 3D printed in black nylon. It's articulated, it's flexible, it moves like fabric. I think there's 12,000 crystals on the gown, and there's 3,000 unique moving parts. There's 3,000 unique articulated joints in the dress. Every piece is different. Not one piece can be gotten off the shelf. At first glance, it appears to be pretty simple. But when you look at this shot, you can see the patterns differentiating to her body. It's opening and closing where we want privacy. It's conforming to her curvature of her body, and there's a lot of curvature. You can see some of the details. So Michael had come to me with this idea. He wanted to look at a Fibonacci spiral, and he was playing around, and we were going back and forth. We actually never met. The entire project we worked on together over Skype. So it was an entirely virtual project. We didn't meet until the day the dress was unveiled. So it was kind of surreal, both seeing the dress and him for the first time. So these initial sketches were done in 2D. There was a lot of work that had to be done to make this work in 3D. One of the first things that we realized was that although a great diagram, projecting spirals onto the body was causing a lot of production and geometric and fabrication issues. We wanted everything on the dress to be flexible. We wanted it to be soft. We wanted it to be like a fabric. I mean, until this point, everybody had done really sculptural pieces that they were hanging off of the body with 3D printing. We wanted to really make an argument for this as something that could be worn. And we were successful. It was a dress that she was able to dance and sit in, move down. Move around. I have a video. The whole dress only weighs 11 pounds, which is actually, I think, 70% lighter than what she normally wears on stage. So it's not something you're going to go to the grocery store in, but it is a practical garment, and especially for the purpose of stage wear. So what we started doing was, okay, how can we take this concept and apply it to 3D? So the spiral was then wrapping around the body, and we mirrored the two spirals on top of each other, and we developed this sort of Chinese finger trap lattice that would wrap around the body. And geometrically, that works, and it'll work in 3D, and the patterning would be consistent across the entire body. The challenge we then had was, okay, how do we get that to respond to the dress? How do we get to respond to the kind of draping we'd want? So that was actually done separately. So the patterning and the form of the dress were two independent investigations. They were two independent computer models. This is the digital model. It was modeled actually in Autodesk Maya, which is commonly used in entertainment industry. Created a polygon model. We sculpted the dress together, screen share, real time. These are one of the earlier drafts, and one of the things you can see is that what we started to do is we started using the way the surface was constructed in the computer to control the placement and development of the pattern. So if you look in the back, how you can see the lines are starting to come together. Even at this low resolution, we're creating density there, right? And that carries through, and it helps us understand. So what we're doing is, yes, we're sculpting the dress, but actually more than that is we're starting to lay down an underlying logic of how the surface works that's going to dictate the way the pattern works, right? And it's, and people say, oh, you just press print, but the truth is this is a different kind of materiality, and I think it's something that designers need to begin to realize, because the construction of that surface has everything to do with how this pattern is going to be distributed. And you can see here how that works. This was the final model. This was the final dress that we sent into production. And you can see what we did here is actually, again, we actually used the polygons to create the structure for how the pattern would lay out. So it was actually a surface modeling exercise here to develop that pattern. And we did end up with spirals. If you follow any one of those curves up around the body, they all make perfect spirals that wrap up around the body. We looked at other things. We experimented with other types of surface tessellations. Once we had that as a kind of framework, we tried mapping lots of different patterns onto it. Some more successful than others. I think this was my favorite. Okay. So this is actually that surface and this component are actually the dress. You could compress the entire thing down to that. It's a surface and a box with a quarter ring in it. And if you notice, you mirror it over and it completes the pattern, right? And you can see in the back here that the ring completes itself as it tiles over. So it was really important that the surface be geometrically consistent and that we had four-sided corners so that the geometry can complete itself. It's like a tile. It's the same as a tile. And each one is torqued a little bit to conform to the surface. So these are actually three-dimensional rings. It's not like a normal chainmail where you would have like a jump ring that's flat. They're all torqued 3D to the body, to what the shape of the body is at that point. So it's highly specific. If anything breaks, you can't go to the hardware store and replace it. These are the machines it was made on. It's an EOS laser sintering machine. It uses a laser to burn powdered nylon in order to create a rigid form. The reason we used this technology and not one of the others was that we knew we were going to have to make very detailed parts, and I'll show you how detailed in a moment. Some of them are, I think they're 0.05 millimeters thick. And we knew that it was all very geometrically complex, and those pieces had to be able to support themselves during the construction process. Because don't forget, when you're 3D printing something, it's building it up layer by layer. So if it's not supported during the build process, it's going to collapse. And so we needed something that would either have a soluble scaffolding or some kind of scaffolding or support material that could be easily removed without breaking what would be very fragile material if you started trying to snap things off. This is how it comes out of the machine. And like I said, people always say, who says craftsmanship is dead? This is a really messy process. It comes out of the machine. It's in this block of powder. And then you have to take it off. And there's a lot of surface area, so the powder is going to cling. It looks like a polar bear did this or something. It looks like snow. Cleaning it out. It was a very laborious process. I believe it took 3 days to finish all the printing and production for the dress. There were about 12 parts, which really isn't a lot. Considering all the complexity and variation in the dress, it's actually very fast. It's being blown out with an air gun. The shoulders were done rigid. These are the shoulder pieces because we wanted them to kind of maintain the structure. We had a very specific shape we wanted it to hold. And each one of those articulated joints had to be cleaned out individually. Like I said, there's about 1 millimeter space between that ring and the linear member. So it was a somewhat painstaking process. You can see him going through one by one and cleaning that out. So this is how it comes out of the machine. You can see it's very flexible, fabric-like. Pieces were then sent off to LA. I'm going to rush a little bit because I've got a 10-minute warning and I have a lot of new work to show too. Michael was given images, drawings from a digital model to explain how the parts go back together. A 3D printed jump ring was made custom that could be snapped back together and numbered so that they can put all the pieces back in line. Like I said, each part is custom made. This shows you how thin it is. You know, it's like 0.5 millimeter thick. So incredible resolution we're able to get. These are the pieces after dyeing, and this is the detail of the crystals applied to the surface. So you can see when she walks, you can see it moves, it sways, it moves like a dress. I mean, aside from the shoulders, which are solid, everything else is flexible, and she can bend and do everything she needs to do. So since then, one of the other projects we've gotten involved in the studio is we've started running educational programs. Like I said, it's a new material, it's a new way of working, and I think it's really important that designers start to find intelligent and meaningful ways to engage this material. Like I said, it introduces an entirely new manufacturing paradigm, a new formal paradigm. It's a game-changing technology, and it's a disruptive technology. And I think it's something that most academic institutions are not really ready to deal with. So we were running these about twice a year. We're going to do the next one in January. This was some results from what we did in the summer. So we took 12 students, and we took them through the whole process, beginning to end, designing in a computer, working with designing with algorithms, designing with computer programs. I'm going to show some videos of some of these animations. I'm just going to blow through this. These are some of the exercises in the first week. These were all done on a MakerBot. These projects are done in collaboration with MakerBot. And the reason we work with MakerBot is because it's, as a printing technology, it's very accessible. And one of the things you're able to do is you're able to not only print complex geometry, but you're able to tune the way the printer lays the material down. And for a student who's trying to engage this really as more of a way of outputting form, but actually as a way of producing new materials, that's very important to control how the material's built. It's all about process and even processes of production. They're being robotically built, and you can integrate, as I'm going to show in a little bit, you can integrate variation on the fly and create materials that change property within themselves. We also 3D scanned a model, so we used the digital data from her body to generate the forms. And the students were using flocking algorithms, which I'll show here, to generate the dress morphology. And this was done in collaboration with Casey Rehm. So you can see here, this is her body as a point cloud that these agents are responding to. So it's a flocking simulation that's running across the body. The body becomes a container for an artificial intelligence. And that's what's helping us generate these forms. And they generate a lot of variation. I mean, this one's conforming close to the surface of the body, but if you look at this one from another student, they let the agents sort of leave the surface. And what it's starting to do is it's starting to dissolve the silhouette, and it's becoming less of a bodysuit, and it's becoming more of a volume. And it's a very different thing. So it's not, it's not really, you don't read the math, you don't read the system. You're just being able to kind of treat the system like a material. You're treating, what we're doing here is we're taking media and we're making material. So the designers need to become very proficient in manipulating media, manipulating virtual data that's going to translate itself into physical objects. These are some of the renderings from the students' projects. This is the final dress that they produced together after they worked in groups to make their own. They sort of combined all the techniques they developed to produce one dress. These are the parts. It's made in a flexible polymer that MakerBot makes. It's a combination of a flexible polymer, and it's also a bio-based, a plant-based polymer called PLA. These are some details of it. This is in the construction process, so it's not really cleaned yet. This is the dress on the form. We're dressing the model. Hair and makeup. We did a photo shoot at the end. I love this video because I gave the photographer some, as reference, photographs from old vampire movies, and I love how the shadows become a character. And he didn't get in the photo, but we got this on an iPhone. So this is dressing the model, and this was the final dress. And it also is flexible. I mean, it's not articulated like Dita's gown, but the material itself is flexible. And you know, the thinner it gets, the way in which these strands come together and come apart, they create structure. When we were done, we actually uploaded the entire dress to Thingiverse, so it's open source. You can download it, edit it, print it yourself at home. It's a couture gown that you can make for under $400 in a plant-based polymer that you can throw away, so that's pretty cool. All right, and what I'd like to close on, I think, is some of the research we're doing in the studio that I'm the most excited about. This is an MRI. It's a black and white image. And the reason this is so interesting to me is there's two color values here. There's black and white. And when you use them, I don't know if any of you have used MRI software, but what you're able to do is you're able to use those tonal values to separate out different types of materials. So if I want to see the skeleton, I'm going to pull the most white pixels out. If I want to see where the fatty tissue is, it's some tone of gray. You define a threshold in order to create material difference. 3D printers work the same way. It's a set of sections that are stacked up. And some of the most recent collaborations we're doing with Stratasys right now is thinking about materials like this. Thinking about materials as a video, as an animation, as something that changes in time and section, that has differentiating material properties. This is a handbag we're designing in the studio. We're working through some of this technology with, and we're applying it to a hinge. We want the material to differentiate itself, have moving parts, and come out fully assembled. These are just some conceptual renderings of where it's going. So these are some early prototypes. This is before we realized what we could do. We were thinking, oh, we'll just have bands of rigid or soft. But what ended up working out really well is that actually we don't need to have horizontal banding. We can actually just differentiate material in section, use a rigid material in the back to reinforce it, and then blend into a rubber. And the rubber was tearing, so by fading into the rubber, we actually increased the surface tension so the two materials couldn't delaminate. So you're able to tune the material down to like the micron. The level of control that you have, you're actually engineering your own materials as you're working. So the earlier versions were ripping. This was the version that actually worked. And it went through a lot of cycles, didn't tear. And this is a cross-section through that material. So like I said earlier, you know, black is the acrylic, and the white is the rubber. So that mix is what made something a lot stronger than what was actually coming out of the printer initially. So back to this MRI, then we went back and we started thinking, oh wait, that's pretty cool, because the material at first was brittle and it didn't seem to have a lot of applications for fashion. But we thought, well, look at all this kind of complexity that's in the body, and we're looking at these images, because this is the technique we use in the studio a lot for manifesting form. So we thought, well, could we make textiles like this? Could we make textiles that were blending from clear to something elastic? Could we make textiles that were going through different levels of porosity, things that could be very specific, like we had done with the early laser cut work, but this time trying to do it in 3D and not just creating holes, but actually differentiating material properties and doing that seamlessly from one state to the other. This is a cross-section. So also, and they're dimensional and they're thick. This is a video of all the cross-sections through that surface. So what you'll notice here is that there's only two pixel colors here. There's red and white. But what you're seeing is a lot of different tones of pink. And these are different degrees because we're mixing a rubber and acrylic. So these are different tones of flexibility. The different tones reflect different levels of transparency. We're mixing materials on the fly algorithmically, so we're able to deal with a large amount of complexity and derive not only complex ornamentation, but complex material properties that are changing throughout the section of the material. These are some of the results, some of the photographs from the prints. So they're not just renderings, they're actually real. This is a close-up of the one you were just looking at. And these are actually all shelled in a clear acrylic, which is what gives it that very, very, very thin layer. So it's still flexible. That's what gives it that kind of shine. And different parts of it have more acrylic than others. This is one where the rubber actually will fade away. If we look at this detail here, you can see where the rubber blends in with the acrylic, and it makes these really beautiful, kind of deep. The light travels through it in a really, really gorgeous way. And you can see here where the strands are dissolving into the clear. Just so now that you've seen that, you can get a sense for how the materials differentiate and how these images are used to control material properties and form. And that actually concludes my talk. I'll take questions now.
Hello, hello. Yeah, we're just going to have a couple of minutes for questions for Francis. Thank you very much. That was fascinating. I'm sure everyone will agree. So, yeah, questions from the floor. Yeah.
Thank you. So, what software platforms do you use for managing the algorithms that you develop?
It's a lot. There's a lot of different software platforms we're using. I think I have every 3D modeling software on the market on my computer. They're all good at different things. The computational work at this point is mostly done in processing. A little bit of RhinoScript, a little bit of Grasshopper, but I would say processing has become a really powerful development environment for us.
Great, thank you.
Yeah. Yeah.
Other questions over here?
Hi. When you showed the image of the chair, you talked about how we're really looking at a mass manufacturing reality. But then you've also sort of mentioned sort of building things to a luxury standard. And so I'm kind of curious about your sense of the value of these materials and the value of the designs, and whether you see these as products that could potentially be distributed in a mass market, or whether you see them as being more applicable to kind of luxury consumption.
Yeah, it's an interesting question because it's something I'm thinking about a lot. On one level, I think about this. I think it could be potentially really powerful for a luxury brand, where their value is established really by creating exclusivity, right? And one of the problems with luxury brands and being able to relate to a younger generation is dealing a lot with social media, which kind of dilutes your brand. And you don't want ubiquity. You don't want to be everywhere. The advantage here is that everything can be a little bit unique. So technically, no matter how big your production run is, everything you own is scarce. The question is, when you can buy something in Kmart at the same price, how do you maintain that level of exclusivity? But the truth of the matter is also, there's a lot of hand finishing that goes into the work that I do. And I think that's what's going to probably set the work apart. I don't think that's going to change any time in the near future. But I think it's something that luxury brands need to be aware of, because like these kind of complexities, and they're not going to be. They're going to be a lot more ubiquitous. It's going to be like that kind of minimalist form that we've gotten from modernism, that kind of was the benchmark of mass production, is really not going to be the case anymore. So luxury brands are going to have to start to find new ways of differentiating themselves.
Thank you. One more question, I think, from the floor. Anyone? No? Someone at the back, right at the back, I'll do some running. Yeah.
Hi, this might be really boring, I don't know, but what happens to all the powder? Like after, can you reuse it or?
Yes, the powder gets reused.
Okay.
Yeah.
Boring.
Good. Sounds a good
So
question.
it's a good sustainability question that we need to be mindful of. Thank you very much, Francis. Thanks very much. Round.